Hello, welcome to our hackathon demo of our project, Rogue. The problem we are trying to solve is about artificial intelligence adoption for doctors. What we believe is that doctors should not trust AI tools. They should be able to verify if those AI models actually work for them. There are so many models on the market, and there are so many vendors, and I believe doctors will finally have private models in the future as well. Another problem is that there are always bias within these models, and bias is always evenly distributed. So one model may work very well for the general public, but it may not work very well for one specific doctor. And I believe the doctor should be empowered to know if the AI model just doesn't work for their patients. So our question here is, how do you know if your AI has gone rogue? Introducing Rogue, continuous integration AI for doctors. Continuous integration and continuous delivery is a known concept for tech industry. I believe it's the right solution for driving AI adoption for doctors. For this app, we have a couple functionalities. Firstly is that doctors can log in and monitor if the AI models and AI tools are performing as expected. We'll give out warnings about overconfidence, or the AI model might be confused. In this case, doctors should not use them. And we can give status as expected, so doctors will have confidence in using those. Another feature is that doctor can always upload their private patient data so that these models can be somehow back-tested based on existing private data. Let's go into a demo. Okay, this is a screenshot. So good morning, doctor. Here are text summary models available for use today. Here we are evaluating these model performances. You can see that GPT-4 today is overly confident. And when they are overly confident, we should always use caution and maybe choose something else if available, like Llama 300B. It's performing as expected. And on the right side, you can see the historical performance of each models. You can see that they were overly confident on the other day, and today they are still overly confident. And for Llama 300B here, you can see that it has been performing as expected for the past couple of days and only had a couple incidents couple weeks before. Right now, we can also click into each of these verdicts and see how they actually perform in the real world. So right here, the doctor has already put in some of the patient information, and based on these text inputs, each AI model is supposed to give an answer. And right here, you can see that there's human expert input, which comes from the doctor. So right here, we are comparing the human expert input with the output of each artificial intelligence models. Right here, you can see that does patient like, this question will be, does patient like vanilla ice cream? So doctor will put, I don't know, because that's not discussed within this transcript. But you can see that some models here actually answer no, or some even answer yes. So in this case, this model will be overconfident, and I don't know will be the correct answer. And let's put a new question and put our artificial intelligence models to the test. Does patient enjoy skiing? So right here, you can see that our latest question was updated. And for the Google's FLAN output, you will correctly say, I don't know. And for the smaller FLAN, you would say no, which is actually wrong in this case. And Llama 7B, being a very small model, the output is not actually in the correct format. And yeah, these are some runtime errors because this model specifically is down. It's not available for inference. And you can see that GPT here gave correct answer for both of their models. Let's pull another question about patients' children. So in this case, I think children was mentioned specifically that they have at least one son. So my question would be, how many children does patient have any children? Let's check the results. So Flan correctly says yes, and the smaller Flan is actually busy doing something else. And here you can see that GPT said yes and gave some context about the answer. Let's give you another challenge. Does patient have difficulty seeing? So right here, you can see that in the transcript, it's explicitly mentioned that patient has blurred vision. So I want to see the output of that. For this question, the bigger Flan answered yes, which was correct. And you can see that GPT answered correctly for both of their models, and he actually gave even more context. So with this framework, we empower doctors to use their actual patient data in evaluating these models, which we believe will help doctor understand how efficient and how useful are these AI models, and it can help doctors to decide if there are any bias involved for any of these models. So these are some screenshots from our app. I believe the safety is paramount, and even if models are black box, we can still do our best to automate the output verification part. So all these model evaluations will run in the background, and for each morning, doctor can just log in and see what models are available and what models are performing correctly. And another great feature I think about this app is that doctors have access to this private data, which is the data of their past patients. And I think this will be most relevant in evaluating whether these AI models actually work for the doctor and for the doctor's audience. For future expansion, right now we have text-to-text summarization models to test, and I believe the same framework can be applied to audio transcription and even image recognition. And another feature I think we can add is about AI performance sharing. So doctors can share those statistics and status, how well does their model work without sharing their past patient data. I believe this will be very valuable, not just for doctors, but also for AI model tech companies. So what we want here is to drive AI models adoption. And some technology we used, Next.js, Tailwind, we used AWS for model hosting. Thank you, sponsors. And Hugging Face for inference model hosting. And we used a lot of Hugging Face free inference. Thank you, Hugging Face. And we used Google Flan, and Nebula's clinical node sample was great inspiration to us. On top of that, we also used OpenAI's GPT-3 and GPT 3.5. Thank you. This concludes our demo, and I hope you can share the assignment I have. Here's a summary of our team and how their expertise come into play here for this project. Alexa has the most medical expertise, and she did a lot of prompt engineering and JavaScript engineering for this project. She's head of product engineering at postad.com. Occupational health finally works. And for Hong, He did JavaScript engineering and CSS. On top of that, he also did some designs for this project.